Hello everyone, welcome to Dr. Ravi's Academy. In today's lecture, you will be understanding the expression for centrifugal tension in a belt drive. Let us consider a belt drive, a flat belt drive. The bottom one is the driver and the top one is the driven or follower pulley and mounted by means of a flat belt. Assume that it is rotating in clockwise direction. The direction of the rotation is clockwise. And let us select an elemental belt which is indicated here at an angle theta from theta and include angle is d theta. This particular element is magnified here. The magnified view of the element, let us observe this and let us consider m is the mass per unit length. Mass per unit length of the belt. When a mass is revolving about a center which will undergo centrifugal tension, which will experience centrifugal tension, that is what is exactly Fc. When a belt is pulling radially outward, which leads to increase in the tension, both sides of the belt, that is Tc and Tc, at an angle d theta by 2 and d theta by 2, and as you know, this total angle is d theta. Now let us consider equilibrium of this particular belt, element of the belt, and write down sigma Fy is equals to 0, sum of the forces along the vertical direction. So that equation is Fc is positive, which is pointing upwards, and the component of Tc along vertical line is minus Tc, and angle is sine d theta by 2, which is the left side tensile force, that is Tc. You have right side also, that is Tc sine d theta by 2 is equals to 0. This is what is your sigma Fy, and further simplify, you have Fc is equals to, you take the other side, that is 2 Tc sine d theta by 2. For small angles, this d theta, your sine d theta by 2 becomes d theta by 2. And if you substitute this, you are going to get Fc is equals to 2 times Tc into d theta by 2, and 2 gets cancelled, and you have, this is Tc into d theta. Let us call this is equation 1. And write the expression for the centrifugal force Fc. As you know very well, that is Fc is equals to, it is elemental mass dm into, it is v square by radius of the pulley, that is r. Radius of the pulley is r, and substitute this dm. And as you know that m is the mass per unit length, if you multiply elemental length, that is r d theta, so you are substituting that dm is m times, it is r d theta is the elemental length into v square by r. So r gets cancelled, and you have Fc value. Substitute this Fc value into equation 1. You have m into d theta into v square is equals to Tc, the right hand side term, that is into d theta. D theta gets cancelled, and you have Tc is equals to mv square. This is the required expression for the centrifugal tension of a belt, where m is the mass per unit length and v is the velocity of the belt. You can calculate the centrifugal tension developed because of this particular mass. Thank you.